we are looking at a problem from 8.1. We're given a graph, we're given a scale factor, and then we are asked to find the image. When I snipped this out from the original, I forgot to snip the directions, but the directions are to find the coordinates of the image and graph. So we can put that on here. Find image coordinates and then graph. Okay, so first off, we should notice that our scale factor is less than 1. Our k value is 1/3. So this thing is going to shrink. It is a reduction. It's going to get smaller. The other thing that we need to make very clear is right now we are always shrinking with respect to the origin. So this thing is going to shrink down closer to the origin. And that's kind of nice because that allows us to do a couple of tricks here. One of them is that when we need to find a new point, so when we're going to find our new point, we're going to take any of the original points, and we're just going to take our scale factor k, and we're going to multiply that by the x value, and then our scale factor, again, k, which in this case is 1/3, times the y value. So to find all my new points, my a prime, my b prime, my c prime, the prime is that notation for the new coordinate, d prime, just a little apostrophe at the end. Every single one of these values is going to get multiplied by 1/3. So this is pretty straightforward. It's 1/3 times 0. A prime is not going to move. It's going to be 0, 0. 1/3 times 0 is 0. 1/3 times 0 is 0. Now for the next one, I need to do a little bit more math. So what I'm going to do here for b prime, I'll show you a little bit of the work here. We're going to do 1/3 times 3, the k value times this value, and then the k value times this value. So 1/3 again times 3. Now these numbers are nice. You can likely do this in your head. 1/3 of 3 is 1. But if you don't feel comfortable with that, you can always use the calculator. 1/3 is just a fraction. I always enter it as a division problem in parentheses. So 1/3 times 3, and you can see it gives me 1. So my b prime is going to be 1, 1, right? Because I do that process twice. Then for c prime, I'm going to do the same thing, right? I'm going to do my 1/3 times 6. And then it's my 1/3 times 0. I didn't really write it out for 0, 0, but it's just 1/3 of it. 1/3 of 6 is 2, but if you want the calculator to do the work for you, we can just in parentheses. My fractions I always put in parentheses. They're a division problem, so 1 divided by 3 times 6, it's going to be 2. So this is 2, 0. And then d prime, I've really already done this math. 1/3 of 3, I'm going to do that again. That's going to be 1. And then 1/3 of -3 is the same thing, but it's a negative. So it's just going to be 1, -1. And again, you can plug it in the calculator if you don't feel super comfortable with that. I'm going to do all my prime points here in red. So my a prime is in that same location. I'll just label it as a prime as well. B prime is at 1, 1. So here it is, b prime. C prime is at 2, 0. And d prime is at 1, -1. So here it is, d prime. And you can see that that did make a nice little square, and we can see how visually it has shrunk down to the origin. The scale factor is 1/3, so any of the corresponding side lengths are going to be 1/3 the length. My original A to B is this long, and then my 1/3 A prime B prime is that long. It's kind of hard to tell the lengths here because we're on a diagonal, but we've talked about using kind of scale factor as a tool. We're going up 1 to the right 3, and we do that 3 times here on the original purple line. But then we only have to do that once to A prime, B prime on the red line. So it is 1 out of 3 total slope ratios that we would use. Okay, so I hope that's helpful. These are our new points. There they are graphed. This process right here, long bell, really helpful and important for finding these new coordinates. Take all of your original coordinates and just multiply each x value and y value by the scale factor. Hope that's helpful. Message me anytime with questions.